Hello friends, welcome back. In this tutorial, we will study about dynamic programming. Dynamic programming is an algorithm design technique. It is typically applied to optimization problems. In optimization problems, there can be many possible solutions and each solution has a value. And we want to find a solution with optimal value, that is with the minimum or maximum value. For example, suppose we have to find the shortest path between city A and city B, right? Suppose we have to find the shortest path between city A and city B. Then this problem is an optimization problem because this problem has many solutions because there are many paths between city A and city B, right? But we have to find that path which has shortest distance, right? Here between city A and city B there are many paths, and with each path there is a value, right? Each path has a particular distance, right? Now we have to find a path with minimum distance, right? So we have to find a solution with optimal value, right? We have to find the solution with minimum value. We have to find that path whose distance is minimum, right? So this problem is an optimization problem, right? Dynamic programming solves the problem by combining the solution to subproblems. These subproblems are not independent. They share sub-subproblems. Divide and conquer method also solves problems by combining the solutions to subproblems. But divide and conquer algorithms partition the problem into independent subproblems. Whereas dynamic programming is applicable when the subproblems are not independent. They share sub-subproblems. Suppose a problem n is solved by combining the solutions of its subproblems a and b. And subproblem A is solved by combining the solutions of subproblems x and y. And subproblem B is solved by combining the solutions of subproblems y and z. Now these subproblems A and B are not independent. They share subproblem y, right? To solve subproblem A and subproblem B, subproblem y needs to be solved. If we solve subproblem A and B like as they have to be solved by divide and conquer algorithm, then the subproblem y will be solved twice. Once in getting the solution of subproblem A and once in getting the solution of subproblem B. A dynamic programming algorithm does not solve common subproblems repeatedly. A dynamic programming algorithm solves every subproblem just once and saves its answer in a table, thereby avoiding the work for recomputing the answer every time the subproblem is encountered, right? Now, there are two properties that an optimization problem must have in order for dynamic programming to be applicable. One is optimal substructure and another is overlapping subproblems. A problem exhibits optimal substructure if an optimal solution of the problem contains within it optimal solutions to the subproblems, right? So in dynamic programming, we build an optimal solution to the problem from optimal solution of subproblems, right? Second property is overlapping subproblems. An optimization problem has overlapping subproblems if the recursive algorithm to solve this optimization problems revisits the same problem over and over again. As we have discussed earlier, dynamic programming algorithms solves those optimization problems in which subproblems share subproblems. So when algorithms solve these subproblems, common sub-problems are revisited over and over again by algorithm. So dynamic programming algorithm solves each sub-problem only once and stores its solution in a table where it can be looked up when needed.